Good afternoon again. I am John King, Project and Communications Manager with the Center for the Ecology of Infectious Diseases and the Global Infectious Disease Intelligence Consortium here at the University of Georgia. Welcome to the Japanese Encephalitis Virus Symposium's welcome reception. I'm going to turn this over to John Drake, who is the director of both the Center for the Ecology of Infectious Diseases and the Global Infectious Disease Intelligence Consortium. And John will share a couple of thoughts with you. Thank you.
Thanks, John. Let me extend to everyone my welcome in addition. Thanks for joining us this week as we talk about JEV, something that is a concern to many of us and an important scientific topic. What I want to do is just tell you a little bit about the Center for the Ecology of Infectious Diseases. The Center for the Ecology of Infectious Diseases exists here in the School of Ecology at the University of Georgia. The University of Georgia has the first school of ecology in the world. We started off our existence primarily focused on ecosystem ecology. And beginning about 20 years ago, when it was just a nascent field, began to develop a concentration of researchers working in the area of disease ecology. The areas in which the School of Ecology excels include ecosystem ecology, biogeography, sustainability, watershed ecology, evolutionary ecology, and of course, infectious diseases. The center itself was founded in 2016, so we're just about to celebrate our sixth birthday, and comprises members from across the University of Georgia campus. This includes between 90 and 100 researchers, including faculty members, staff scientists, postdocs, graduate students, and even some undergraduates who are doing research with us. These members represent 15 different units at the University of Georgia, including units like the College of Veterinary Medicine, of course, the School of Ecology, the Warnell School of Forestry and Natural Resources, the College of Public Health, departments of entomology, genetics, statistics, and others. Our goal in the center is to bring together diverse researchers to tackle truly challenging and interdisciplinary problems related to the spillover of emerging infectious diseases, the maintenance of infectious diseases in wildlife and human populations, problems related to One Health, as well as understanding parasites and pathogens in animals and wildlife. Since its founding, the CEID has helped faculty at the University of Georgia to recruit more than $5 million in external grants for these interdisciplinary projects. This is, of course, on top of the research grants that are won by many faculty for funding their basic research. Most recently, this $5 million includes a $1 million award from the National Science Foundation as part of the new Predictive Intelligence for Pandemic Prevention program. The project that is being undertaken by the CEID is called Heterogeneous Model Integration for Infectious Disease Intelligence. We believe that there really is not a sufficiently developed comprehensive method for paying attention to disease threats around the world as they emerge, for alerting stakeholders in society, governments, nonprofits, companies, private individuals, and of course scientists to those threats as they develop. But that's what we call infectious disease intelligence. And we also believe that infectious disease intelligence will be supported by the development of new analytical pipelines. Now, this is where scientists like those at the CEID come in. And so with this recent award from NSF, we are seeking to do a demonstration project of the ways in which analytical techniques can be combined in interdisciplinary collaborations. The CEID has a number of what we call service areas. We're focused on training new scientists, communicating with the public and with other scientists. But above all, what we do is we support research. One of the ways we do that is through our working groups. Since its inception, the CEID has had 5 different working groups. 3 of those are current, the forecasting working group, the mapping working group, and a working group that is focused on understanding the role of animal and human behavior and how behavior affects the transmission of infectious diseases. Just as an illustration of the kind of work that's done at the Center for the Ecology of Infectious Diseases, this slide shows the some of the products of the coronavirus working group, a working group that we stood up in January of 2020 as we became increasingly concerned about reports of pneumonia in Wuhan, China. We were one of the first organizations in the United States to develop a tracker that would allow government officials, scientists, and others to pay attention to trends as they were evolving in time. We sourced this tracker with data that initially we ourselves scraped from diverse web sources. It became apparent that what we were seeing in the epidemic was actually transmission that was weeks old due to the incubation period, of course, delays in reporting. So one of our first contributions was what we call the nowcast algorithm, a method that we first developed in the context of understanding Ebola in West Africa. In fact, the current algorithm grew out of a student project related to that initial epidemic. And many other projects that sought to use data analysis and analytical techniques to support situation awareness, decision-making, understanding what interventions might be effective, and general preparation for response. We developed a model in the early phases of this summer that could be used to guide universities like ours as we reopen, trying to do so in a safe and effective way. We worked with the Centers for Disease Control in Atlanta to model the importation risk as that changed over time on a month-to-month basis. The point in showing you this slide is really just to showcase the wide range of analytical techniques, methods that are not routinely used as part of infectious disease intelligence, but we believe can be in the future. And it's our mission, among others, to try and develop that technology for use in the future. In the course of our work on COVID-19, I became increasingly convinced that one of our challenges is to take the information that we have been producing in academia and bring that to decision makers in other sectors. I believe that this idea of infectious disease intelligence has not been sufficiently explored or defined, and one of our goals is to do that in the coming years. In order to create the relationships that will make that possible, 2 years ago, we launched the Global Infectious Disease Intelligence Consortium. The idea behind the consortium is that we want to tighten the connections between academics, who are often at the forefront of new information as it's coming out, and decision makers in different sectors who might be able to make use of that information. By the same token, in academia, we often don't understand the challenges that are facing decision makers. What kind of intelligence is actionable? What kind of questions are operational? And so by creating a virtual or literal kitchen table, bringing together representatives from private industry, government, as well as academia, our hope is to increase the communication and the efficiency of our research. We're really interested in the development of early warning and real-time methods for interpreting outbreak data. We do this using mechanistic models, biostatistics, and data science, including AI. We believe that advanced monitoring and analytics can help the world to anticipate and respond to the next global pandemic. We believe there will be one, and we believe also that preparedness is the best way to mitigate future damages. We think GIDIC has to be a collaboration. It cannot be an academically oriented organization. And for this reason, we are eager to invite representatives of other sectors to join GIDIC and participate with us as we envision the future for infectious disease intelligence. Some of the ways in which GIDIC does this is through the publication of an annual Horizon report. This is a statement of our perceptions of the state of play around the world. The facilitation of roundtables in which we discuss topics of interest to our members, and we try and share information across the membership so that what is learned in one sector can be made of value in another. Webinars are educational events offered by the Center for the Ecology of Infectious Diseases, where we provide training and instruction about new concepts or ideas that we see generating a lot of buzz, but which may be unfamiliar to decision makers that need to separate the signal from the noise. We, of course, have a regular newsletter, and often much of our work with members leads to sponsored research. But perhaps one of the most interesting things that we do in GIDIC is we sponsor and facilitate symposia. And that's where we are today. Japanese encephalitis virus is a longstanding pathogen of concern, a pathogen of pandemic potential that affects both wildlife, livestock, and humans. A recent incursion into Australia, I think, has brought much needed attention to the ecology and evolutionary biology of Japanese encephalitis virus. We are concerned about introductions from Southeast Asia and Australia to other parts of the world, including locations with significant livestock production, human populations that might be at risk, and other circumstances in which introduction of JEV would be especially unwelcome. Our purpose then this week is to bring together the leading experts on Japanese encephalitis virus. We would like to understand what's understood about the ecology, the evolution, the epidemiology of JEV. We want to identify gaps in knowledge, gaps that could perhaps be plugged with research if that research is done in a timely way. I think that the return on the investment in that research could be tremendous in terms of preventing or mitigating damages from any future introductions of JEV. But we also think it's important to understand what information resources are out there, what data is out there, what's understood, to bring this together in the context of a think tank of people who bring diverse perspectives and training, access to resources and information together to brainstorm and anticipate JEV in a way that we have not anticipated the spread of many other infectious diseases around the world. So with that, I again thank you for participating in our symposium this week. And I want to turn the floor back over to John King, who will provide just a few more details about the schedule and our plans for the next couple of days.